Hello, one last time. This, I believe, will be the last video in this series um, of review videos going over circular motion and gravity problems that were provided to AP Physics students. We have two problems that I haven't gone over. First one being number 15 from the packet. At what frequency must a particle rotate 7 centimeters if it is to experience an acceleration of 125,000 Gs. So 125,000 Gs is a unit of acceleration. And what they're saying is it's accelerating at 125,000 times what we use as acceleration of gravity here on Earth. G equals 9.8 meters per second squared. So we're given acceleration and we're given the radius of curvature that this particle is going around. So it's rotating at 7.00 centimeters, and it's experiencing an acceleration that is equal to that, but really it's just that 1,200 or 125,000 times 9.8. And that gives us a number for acceleration as about 1,225,000. And the units now are meters per second squared. We want to know the frequency, and we can relate frequency to the motion of an object in a circle by using velocity. So if something's moving in a circle, it has a tangential velocity of 2 pi r over t. This is the same thing as 2 pi r times the frequency, since frequency is equal to 1 over t, which is the period. If something's going in a circle, it's accelerating centripetally and has a tangential velocity. You can represent this as if it's going clockwise. Then the tangential velocity can be represented by that vector. And acceleration, if you're going in a circle, is v squared over r. We can substitute this equation for v so that we're left with something that has frequency in it. This whole thing is squared. We have acceleration, we have r, and now we have, we're almost to an equation. We can kind of see it, almost to an equation that has the two things that we do know and the one thing that we don't know, the thing that we want. And so I'm going to keep simplifying this so that I isolate f. This is 4 pi squared f squared. And this is, you're left with 1r on top. And solving for f gives you a is divided by this whole thing. And you get a number that's about 66.6 hertz. And hertz is the unit of frequency. It's an inverse second. Keep in mind, what you're plugging in for r is not 7. If we're using this as our r, we always have to convert to the standard units. And so rather than r being 7, we have to convert it to meters, and r is 0.07 meters. The last one, number 16, is kind of a fun one. It says, Two objects attract each other gravitationally with a force of 2.5 times 10 to the minus 10 newtons when they're 0.25 meters apart. Their total mass is 4 kilograms. Find their individual masses. So we're not given one of the masses right away. We just know that when you add them up, you get 4. And so this is a little twist on a classic force of gravity problem. Since we're not on Earth, or we are on Earth, we can assume we're on Earth, but the force of gravity we're trying to calculate is between two objects. So we're going to be using Newton's law of gravitation to find out what the force of gravity is between those two objects. And that's the equation. Force of gravity is given as 2.5 times 10 to the minus 10 newtons. The mass of 1, well, we don't know. We just know that when you add them up, you get 4 kilograms. So we can say that one of them is just equal to 4 minus the other one. Well, given the distance that they're separated by, 0.25 meters. And that's all we're given. So what are their masses? G is always 6.67 times 10 to the minus 11. And this can be found in your book, in the equation sheet, in your notes. You don't need to memorize it. And so I'm just going to start plugging stuff in and see what we get. Because I know everything else in this equation except for the masses. But I can substitute one of the masses in terms of the other. So I'm left with just one unknown. I'll show you what I mean. So I'm substituting for force of gravity. Oops. That's equal to the 6.67. And then substituting for mass 1, actually mass 2. Let's substitute for mass 2. I know mass 1 is the same thing as 4 minus mass 2, and then mass 2 is just mass 2. And that's all over the distance that separates them squared. Don't forget that square. So now I have an equation where the only thing I don't know is the second mass, but once I find that second mass, then I can just subtract it from 4 to find the first mass. So it all depends on this condition that you set. What you end up with is this expression where you multiply mass 2, 4 minus mass 2, and they equal 2.34. I used Pythagorean theorem. I expanded this. So this was negative mass 2 squared plus 4 mass 2 minus 2.34 is equal to 0. And using, did I say Pythagorean theorem? Quadratic formula. Don't know what I said a second ago, but I use a quadratic formula, negative b plus minus the square root of b squared minus 4ac all over 2a, where those are my values. And just plugging that in, you get some numbers that actually add up to 4, which is what we're looking for. So you get 3.3 kilograms, and the second mass will be 0.71. kilograms. These may be reversed depending on how you did it, but it doesn't matter which number mass you end up with. You just need to find the mass of both of them. And they add up to 4.